All right, welcome back. So this is a second installment for Chapter 3 for Intro to Stats. We're going to talk about mean versus median and what the shapes mean and all of that kind of fun stuff. So let me go ahead and share my screen and we'll see if we can't get started. Right? Okay, so there is actually a goal here. All right. Now, we left off we talked about mean, median, and mode. So remember mean. Okay, we have sample mean. Okay, that's X bar, that's called X bar. That's a statistic. We have the population mean. Okay, that's mu. This guy here is a little u for Greek letter. It's called mu. Okay, and all it is just add up all the numbers, divide by the number of things you added up. Okay, for median, it was a little trickier because if your n equals the number of things, number of observations. Okay, if n was even, then what we do is we average the n over 2 and n over 2 plus 1. We average the middle and the thing one up from the middle. We average them together, and that gives us the position of the median, and then whatever's in that position is what we report. If n is odd, okay, then it's just n plus 1 divided by 2. And again, that tells us the position. Okay, so whatever happens to be in that position, we're going to go ahead and report the value that is in that position. Okay, the answer is not the position. The answer is the value in that position. When we start doing homework walkthroughs, you'll see a little bit more. Okay, one of the things that they ask about, okay, when should you use which? Okay, the difference between median versus mean. It's the middle. Okay, generally, if you don't have a number, you want to use mode because that tells you the most common thing. So if I asked you like, hey, what's everybody's favorite soft drink? Like I can't add Coke plus Dr. Pepper together and divide by 2. Like that's not going to happen. Okay. So what we have to do is just pick out the thing that happens the most often. That's our mode. So the most frequent mode. Okay. So which one should you use? If you have very disparate, so mean versus median. Okay. If you have very disparate, very separate measures, okay, usually it has to do with property values or salaries or wealth, things like that, then median is generally the better measure of the center rather than the mean. Mean's still good, okay, but if you have things that are like way out, like you have measurements that are really far away from each other, then mean is nice, but you can get an inflated mean because maybe you have like salaries, right? And maybe you have a whole bunch of salaries like this. And then you've got like the CEO of the company that's doing something like that. I don't want to say the average because maybe you've got like this, not putting numbers on here on purpose. Maybe you've got like somebody who doesn't make very much and somebody makes a whole heck of a lot. You don't want to average these together and have this be the measure of center you want to use. So when I was in high school, just to give away my age here, one of the things they asked you is like, okay, what do you want to be when you grow up? I have no idea. So I ended up here. But I played the saxophone. I would say mediocre. Okay. But they would say, okay, well, you want to be a musician. So Madonna was really popular at the time. That is, Michael Jackson was very popular at the time. So let's take all the earnings from Madonna and Michael Jackson and all the other musicians that were working at the time, add up all their salaries, divide by how many we added up, and then give you the value. And it was a pretty, it was a pretty nice value. Okay, I mean, it was like a $35,000 a year kind of a salary. Like, okay, look, I am nowhere nowhere near talented to be Michael Jackson. I'm nowhere near as talented to be Madonna. That's just not happening. So, but I don't want musicians. I don't want the musicians' average salary, which is what they told me. They said, "Hey, you can make a good living doing this." Like, no, I was at least good enough to figure out like I don't need the musician's average salary. I'm going to be working in like Atlantic City because I live in Pennsylvania. So I need the average musician's salary. So if you're lucky, you get a couple of gigs working a casino in Atlantic City, or maybe you get to work on a cruise ship or something like that. And you get to be in the band for that. That is not Madonna quality level income. Okay? You're not raking it in like Michael Jackson here. Okay, you're lucky if you're making a couple $100 a week. That's not the kind of salary that Madonna and Michael Jackson are getting. I'm the average musician. That's what I want to know. Like, what's your typical musician going to be? Not add up all the musicians and divide. Okay. So in this case, the median, I want the average musician salary. Okay. I want the middle value for the salary for a musician. I don't want the mean that is all of the salaries added up. Okay. So those are different numbers. This is not going to be very useful to me. Whereas the average musician salary, I'm like, yay, you can make, $8,000 a year. I'm like, yay, I guess math teacher's my next best choice. I'll take that. So not too bad. But that's why you want to use median versus mean. So if you have numbers that are really, really far apart, okay, if you're comparing like GPV, gross national product or gross domestic products for countries, a lot of countries have a wide variety in what their GDP is. So pick the median one because that gives you a better measure of what the center is rather than what the average is. Okay, so that's a big thing that people will argue over. If you don't know, generally pick the mean because the mean uses all of the values of all of the observations that went into it. But if you've got this histogram that has really far outlying kind of points here, then I'd say, the median is probably going to be a better choice for you to use. Okay, and usually you're going to know something about the thing that you're studying, so you're going to have an idea of what's going on here. Okay, if you're studying gas mileages, unless you've got like a whole bunch of hybrid cars, if you've got a bunch of, I guess you could do a bunch of hybrid cars, and then you could also add in like the big truck things. You would probably again want to use median, but like if you just got a whole bunch of sedans, they're more or less kind of the same. You want to use mean because that's going to give you the best measure of center. Median if everything is really far apart. Okay, so that's a guideline for what you're going to do. And this is the reason why stats is done usually in groups, is because these are things that people will fight about, and that's okay. You can have different opinions on which one should you use. Okay, but generally is if you have if I'm comparing incomes from different states, you're going to want to use median because the average salary in say Connecticut, New Jersey, California is way different than the average salary of say North Dakota, South Dakota, Alabama. Okay, so that's why we use medians versus means. Okay, because we're trying to get what is going to most accurately represent the center. Okay, now for the homework, they're going to ask you shapes. Okay, shapes of histograms. Okay, there's a couple of shapes we want to know. Okay, so we have a histogram. Again, I'm not putting numbers in here on purpose, but we have something called symmetric. Okay, that means half the data is kind of before the median, half the data is kind of after the median. For a lot of measures, this is a pretty good idea. Like if we're talking about rating intelligence, half the people fall below average, half the people fall above average. I would say that's a fair statement to make. Okay, so symmetric, median and mean are about the same. Okay, so mean is more or less equal to the median. Okay, and for most observations, that's the kind of thing that you're going to be dealing with. Like, hey, how if you're dealing with something industrial, weighing a bunch of you're manufacturing nails, and you weigh out all the nails to say what's the average nail. You're not expecting there to be one problem with nails. Okay, you're expecting most nails are going to weigh about the same, half below average, half above average. We're probably going to be okay with that. So that's a mean. That's what we're going to use. Then we have skew. Okay, so if we have a histogram, okay, and we have say this histogram, we've got some observations that are way over here. This part here is called the tail. Okay, let's see here if you can make a nice horrible picture here for us to kind of remember what's going on here. The reason I asked you, like, hey, what's your favorite dinosaur? So if you kind of draw a really, really crummy dinosaur, don't laugh at me. You'll laugh, that's why. If I'm looking at the weight distribution for this dinosaur, most of the weight is sitting here. If I was going to try to get like what's the center of mass, we're going to get here. But there's a lot of mass. There's a lot of dinosaur left over. Okay. So in this case, this would be called a left-sided skew. If I drew it the other way around, where I would draw the dinosaur here. Oops, let me draw it the other way. Okay. You have a tail going off in this direction. This would be a right skew. The tail is going off to the right. Legs in here. Eyes. That would be our dinosaur here. The tail is going off to the right. So it's a right-sided skew. It's right skew versus left skew. Generally with left skew, I don't see these very often. It's for histograms. It's usually when you're dealing with some kind of an artificial barrier at the top. Okay, so if you're in healthcare and you know, like people have like, we're going to give people 1 week to recover from hip replacement surgery. And you know that most people take all 7 days. You might get some people that are athletic, or maybe they just have really good recovery systems. Like maybe you gave Wolverine a hip replacement. They're going to be out in a day. A lot of people they're going to run up against. Well, the insurance company says you got to go, so that they're going to touch you out at that point. So you're going to end up with a left-sided skew. Not too many here. There could be a tail here where somebody is done very quickly, but most people are leaving at the end of whatever their insurance will pay for. Okay, right-sided skew. This is more common. Okay, so you'll see this when you have something like this, and then we've got histograms laying up like this. Phone calls are generally a right-sided skew. You've got a lot of phone calls end up being like, well, if you grew up in the 80s, okay, you end up with a right-sided skew because sometimes you'll call up, hey, meet me at the movie theater at 10. Or sometimes it's going to be your long lost friend you haven't talked to in years, and you end up talking half the night. And that's what your phone call looks like. You guys don't do that anymore, but that's what we used to do. Okay, so those are different skews. We have one more that I'm going to talk about. The book doesn't talk about this very much. There's kind of a curve. It's called a bathtub curve. Okay, because if I don't draw the little blocks, we draw the little thing where we have some kind of a thing like this, where we have a high frequency at the edges, but a very low frequency in the middle. Okay, this is often related to lifespans. Okay, where most things either break immediately or you're selling them in a garage sale 30 years after you got it. So think about whatever Christmas present you got when you were a child. Chances are you got the toy out of the box and it broke within seconds of you touching it. Okay. Then a lot of times they just kind of end up somewhere in the middle here, where the manufacturer, whoever made the toy, expects it to last about 3 years or whatever, or a year, and then that's fine. And then somebody gets into it and it breaks, and then or a couple of things like you end up with like it doesn't break and you're throwing it out when you move. Okay. So this is very common for lifespans. This is why they turn on computers before they ship them to you, because they want to see, hey, what's going on with the components here? And they can immediately burn out. They don't want to ship you a computer. They pay good money for a computer. They don't want to ship you a laptop that fries the first time you turn it on. Okay, so that's what they do. They turn it on at the factory to make sure it works, see if things are working, and then if not, then it's got a lifespan it's probably not going to break within the first year, which is why they tell you not to buy the warranty. Maybe not break within the second year, but come to the end of its lifespan, they might rate this thing for like a 3-year laptop or 5-year laptop. Come to the end of those 3 or 5 years, you're going to get a lot of things breaking. That's when it's time to replace it. Okay. So this works for lifespans. Okay, sadly, we have infant mortality. So we have people who, we have children that die from 0 to 2. That's sort of infant death syndrome. We have things like that. chances are, if you've made it past that stage of your life, you're a teenager, you're in your 20s, you're in your 30s, you have a very low incidence of dying. Okay, I was reading a study that talked about that people in their 30s and 40s don't have an issue with this particular diet. They don't die. Like it's because people in their 30s and 40s typically don't just die. Okay, I mean you could always be hit by a bus, but generally you're gonna wait. When you're 50, okay, that's sad. When you're 60, that's more sad. But when a 70-year-old person ends up dying, I mean, it's the Queen of England just died, so 96. It's sad. It's not tragic. It's not when the 6-year-old dies. That's tragic, sad, and that's horrible. That's no parent should ever have to go through that. Okay, but there is a natural end to a human life. We are going to experience that, but that's what's called bathtub curve. It technically is symmetric. It's just the opposite of the symmetric they usually talk about. Usually they want to talk about this symmetric. Okay, that's what they usually mean by symmetric. This is technically symmetric too. You could fold it over, and the left side is the same as the right side, but it is a little bit different in when you're interpreting what's going on. Okay, so when they say symmetric, they usually mean this one. Okay, left skewed, remember that's the tail is on the left-hand side. I'm going to show you another dinosaur. So this is left symmetric or left skewed. Okay, skewed, there we go. So remember, it's the direction of the tail. It's not where the hump is. It's not where the median is. Okay, it's the direction of the tail. So that's how you do the horrible dinosaur. Okay? So it's right-tailed. Okay, we're going to be seeing, and this is, again, in practice, you'll see more right-tailed stuff than left-tailed stuff. You're going to see things like that. You don't usually see left-tailed. Okay, but that's the position. And they go on, we talk about this one. So if we talk about mean versus median, if we've got our dinosaur here, right, we've got our, so draw it, I'll try to draw it. Well, we'll draw it so it looks like this. Okay. The 50%, if I want to try to balance, this is a weight distribution, okay? I've got my food on a plate. I've got a whole bunch of salad on one side, and the other side I've got like a burrito here. If I want to balance this finger on my plate, then chances are I'm going to have to put my finger about here on my plate in order to balance it. But there's still a lot of food. I mean, it's all salad, but there's a lot of food sitting on the other side of the plate. So the median, half of the food is probably going to be about here, okay? Whereas the weight is going to be sitting over closer to the peak here. Okay, so when your median is less than your mean, don't memorize this, by the way. They ask you in the homework. I try not to pick questions that do this for quiz questions because this is a thing you could look up. Just realize that if they aren't the same, that means your distribution, it means the data is skewed in one direction. Okay, so if we have our other way around, right? If I'm going to balance, if this is all weights, I'm going to try to balance this on my finger. I might put it over here, but clearly the middle of the data is going to be sitting right here. So I want the mean, right? Or I want the median to be smaller than the mean. I work the same both times, be bigger. Okay, so yeah, the halfway point is here, and they start balancing it somewhere else. So that's what you want to do for this. Again, I try not to ask you too many quiz questions about this because there is a table in your book. You're free to look that up. Okay, but you want to think about where you're balancing and where the halfway point is. Okay, so the halfway point is closer to one side rather than the other. You've got a skewed distribution going on here. Otherwise, if they're about the same, you have a symmetric distribution here. So I'm sorry, that was a clumsy explanation, and I apologize for that. So that's the difference between right-tailed, left-tailed. That's pretty much what we talk about. Again, I try not to pick too many questions like that because it's a lot to try to remember. Okay, to do that. But that's what they mean when they're talking about the tails. That's what they mean when we're talking about like a halfway point. It's one thing versus the average being quite something else. So I'm going to go ahead and stop us here, and then we will go ahead and do a homework walkthrough in the next video. So we're going to